Hi everybody, I'm John Boprosky. I'm glad you're able to join my webinar. And the topic is how to create, build, and simulate IBIS-AMI models using free tools. So at this webinar, I want to make these promises to you. You'll learn where to obtain and use the free Microsoft Visual Studio tool, where to obtain and use the free CMake tool, and based on the example to be discussed, you'll learn how to create the required IBIS and AMI files using templates, how to create the required C++ source code files using templates, how to use an automated modeling building block approach to create the example IBIS-AMI model, and how to use the free SerDesDesign.com channel simulator. So, are you committed to learning about how to create, build, and simulate IBIS-AMI models using free tools? You're attending this, so I believe that this is your commitment, and it's my commitment to give you what you need. So let's get started. So as I go through this webinar, you might want to take screen captures of any slides of interest to you. However, at the end of this webinar, the web materials will be made available to you, and I'll provide you a link at that time that you can copy from the chat window. So, just for your information, all attendees and participants can only see their chats. They can't see chats from other people, and I see everybody's, okay? So we're going to talk about 7 steps to obtain the free Visual Studio tool, to set up the modeling directory structure that leads to the automation, to obtain and use the free CMake tool, to set up IBIS-AMI files using templates, and to set up C++ source code files using templates, and then building your IBIS-AMI model using automation, and then simulate using the free channel simulator. So first, let's talk about the free Visual Studio tool. It's important for these reasons. It's free. It provides a well-structured environment for writing C++ code even when you're not familiar with C++. It supports model building using CMake, which enables builds that are generic for Windows and Linux. In general, you like to deliver IBIS-AMI models for both Windows and Linux. It provides a code debugging environment when the model is used in an application such as a channel simulator. So the current Visual Studio release is 2022, but we'll use the prior release, which is 2019. Now, to get this, you just use this link to get the tool from Microsoft. You have to sign in with your Microsoft account. It's free to have a Microsoft account. Obtain version 16.11 for the 64-bit Windows PC version. And select the download with this option. You can see it's Visual Studio Community 2019 version 16.11. And just click the download button. Okay. So when you do download it, you'll get an executable with some name similar to this. If you look at the properties, you'll see that it is from Microsoft, and it's a valid executable for you to be running on your PC. And when you do install it, just click the desktop environment with C++. You can see I have it circled here. You don't need anything else. That's the one piece that's needed for this. In fact, you don't need to install the entire Visual Studio Edition. And then now you can see that obtaining and installing this free tool is simple. So do you understand, as will be demonstrated later in this webinar, that this tool will make creating IBIS-AMI models easier, more enjoyable, and more effective for you? How does that sound to anyone out there? Simple? Yes. Good. Now, we'd like to set up a directory structure. This directory structure is important for these reasons. It provides a common reference point for all users. It enables the use of automation tools that requires a priori knowledge of the directory structure, because I set things up so that it knows what to do. I'll identify what you can change, what must remain as I list it. And the automation process that I define will work properly with this directory structure. So here it is. On your C drive, on your Windows PC, set up an AMI directory with a subfolder called AMI Solution, subfolder of that called Model Builder and Source, and under Source it'll be AMI-TXFFE. The AMI-TXFFE is just the name of a folder that's going to be for a transmit FFE model that we're going to talk about as part of the demonstration of creating IBIS-AMI models, but that folder could be given any name for any other IBIS-AMI model you create. So this entire directory structure could be located at a root directory other than the AMI root directory, but everything else from under at AMI Solution and on down is what has to remain the same. So, do you agree that this directory structure is simple? It can't be much simpler. And do you understand that only the AMI directory name and the AMI TXFFE directory names can be changed? So, now we want to obtain and use the free CMake tool. Obtaining and using the CMake tool is important for these reasons. It was created by Kitware in response to the need for a powerful cross-platform build environment. It's an open source cross-platform family of tools designed to build, test, and package software. It's widely used by the C++ code developers on the Windows and Linux platforms, both platforms. It has been an established standard process for many years. CMake will be used with Visual Studio in our Windows process, and it's also used on our Linux builds as well, but we won't be talking about Linux builds. So you can obtain the CMake tool from this link. You can take a screen capture of it. And you want to select the binary distribution for Windows 64-bit. And we're using version 3.25.1. Okay. And what you would do is you would take that zip file and place it in the AMI Model Builder directory, AMI/AMI Solution/Model Builder directory, and rename it to just CMake. Okay. Then when you unzip it, it'll have underneath it this bin directory, doc directory, man directory, and share directory. Okay. So now we want to set up some files to use CMake. So we want to customize CMake for our purpose. CMake is a general tool. It needs instructions on what computer OS is being used. It needs instructions on how and where to create the IBIS-AMI model files. It needs instructions on where to place the complete model files. So the above is achieved by using a custom CMake file that completely defines on the following pages. No need to understand CMake, just follow the rules. Okay, so I have a custom CMake instruction file here called SerDes design underbar IBIS-AMI underbar WinX64.CMake. So this will be provided to you at the end of the webinar, and you place it in the CMake folder shown here. And so this CMake file defines the computer OS being used. It defines the instructions on how and where to create the IBIS-AMI model files. It defines the instructions on where to place the completed model files. Now we also want to create a batch file, a Windows batch file, for setting up our configuration. And I'll be providing that to you in the link at the end of this webinar. And this custom configuration file sets the Windows path variable as needed for our automated build. It runs the CMake process as needed for Visual Studio version we're using, and it directs CMake to the IBIS-AMI model directory and files that will be set up in the following pages. And let's see. So I have another file for CMake. It's to be located under the source CMake list.txt. This will be made available to you. And this custom file tells CMake where the CMake tool was installed. It tells CMake where to find the custom CMake setup file defined in the prior slide. And it tells CMake where is the directory containing the source code for the IBIS-AMI model to be created. And then we have another custom CMake file, this one located in the AMI-TXFFE folder. And this one, again, tells CMake where to find the custom CMake setup file defined in the prior slides. It runs the custom CMake macro that I've defined called model add AMI library. And it runs another custom CMake macro that I created called model install AMI model. Now, there's detail here that you really don't need to understand. You just use it. That's part of what automation is about. So, there's a lot of detail in setting up and using the CMake process. Do you agree that it's a relatively straightforward and simple process? I'll be providing you the files and the link at the end of the meeting. And you understand, as it will be demonstrated later in this webinar, that these CMake files will automate the entire process for generating and running the Visual Studio solution infrastructure used to compile, link, and install the IBIS-AMI model files. Is everyone catching what I'm saying here? Let me just see if anyone responds by chat. Okay. Yeah, okay, we've got more responses. Good, thank you. And now we want to set up the IBIS and AMI files. This is important for many reasons. The models follow the IBIS standard currently at version 7.2. It was ratified just last month, not too long ago, January 27th, 2023. And IBIS-AMI models are used in channel simulators for modeling the signal flow in a SerDes system through differential channels. The IBIS file defines the IBIS buffer for the IBIS-AMI model. This is a circuit model with differential output for the transmitter or input for the receiver. The AMI file defines the signal equalization for the IBIS-AMI model. This is a DSP algorithm with no associated impedance properties. For each custom IBIS-AMI model, one needs one IBIS file and at least one AMI file. Based on the IBIS standard, use the established templates that I'll be providing and rules. So here is the IBIS file. It has a differential. So let's talk about the transmitter IBIS buffer. That buffer is defined by an IBIS file, and for each of the differential pins, there is a circuit associated with it that's represented by this circuit diagram. And now this is a simplified circuit representation defined by the IBIS standard. And however, beginning with the 7.0 version, this can alternatively be defined with the S4P file. We won't be talking about the S4P file, but certainly my flow supports S4P. So I'll be providing a custom IBIS file, transmit IBIS buffer file for you, and you would place it in this TXFFE directory. And for simplification, I just set these circuit elements to these values. As you saw on the prior page, there's the different circuit values of C package, L package, R package, C comp, and different tables for power and ground clamp and pull up and pull down and ramp rate. Now these can be set to our other values, but I set them to simple values to start with. The ramp rate is set to a small fraction of the symbol time. And the IBIS file also references the transmit FFE AMI file and the transmit FFE DLL file. It'd be .so on a Linux build. And this IBIS file can be used as a template for other transmit LTI IBIS files. LTI stands for linear and time invariant. This transmitter is linear and time invariant, but the transmit IBIS buffer is the same whether it's linear and time invariant or not. So the AMI file is, for our discussions, the transmit FFE is linear and time invariant and has 3 taps, 1 precursor, the main tap, and 1 postcursor, 1 pole filter, and an output gain block as represented by the signal flow block diagram. This, of course, this TX model signal flow can be changed as needed. And so I'll be providing you the AMI file and the link I'll show you at the end of the meeting. You place it in the TXFFE folder, and it sets the values for the 3 tap values and for the filter corner frequency and for the gain. And again, this AMI file can be used as a template for other transmit LTI AMI files. So we've gone through the setup of the IBIS and AMI files, and though there's a lot of detail in setting it up, do you agree that by using templates, this is really a cookbook and simple process? Do you understand that these IBIS-AMI files define the model for the channel simulator? The AMI signal processing is defined in the CPP file. That's the C++ file to be discussed next. And so we're going to set up the custom source code file. That's important for these reasons. The source code files follow the IBIS standard, and the .h file defines the interface to the channel simulator, and the .cpp file contains the scientific code for the equalization algorithm. The custom C++ code can reference other source code as needed, and based on the IBIS standard, one can use templates and follow rules. So you'll obtain the .h file, the link that I'll provide at the end, and it's a very simple file. The same LTI AMI .h file is used for every LTI AMI model. So all AMI files can be either defined as LTI, which is linear and time invariant, which is used for our example, or as NLTV, which is nonlinear and or time variant. So as I said, this is a generic file used for any LTI AMI model. Then you'll obtain the C++ file at the link I'll be showing you, and you place it in the directory for the TXFFE. Again, the templates can be either for an LTI model or for an NLTV model. It's LTI for our example. And so this generic LTI AMI CPP file is the same for any LTI IBIS AMI model. And in the template, there's only 3 areas that require custom code. All the interfacing to the channel simulator is standard, doesn't need to change. And the 3 areas are for just inserting any additional include file references, an area to process the AMI input parameters, and an area to process the impulse matrix that's where the scientific algorithm goes. Now, do you see that the AMI.h file, it's just reusing an existing template. It doesn't have to change. It's as simple as that. And do you see that the AMI CPP file is based on a template? It has all the boilerplate in place, and there are only 3 insert areas where you put your model-specific code. By using templates, the example TXFFE file, CPP file, though detailed, is made easy to follow. The next step will put it all together to build a model. So far we've done the following. We've obtained the free Microsoft Visual Studio tool. We've set up the Windows directory structure. We've obtained the free CMake tool. We've set up the IBIS and AMI files using templates. We've set up the C++ source code files using templates. Now we'll put all those pieces together to build the IBIS-AMI model. How are we going here for now? Any comments in chat anyone wants to share with me? I can answer questions now or at the end of the meeting. So effectively, we've had 8 files that we've defined with this directory structure. Okay, this includes the custom CMake files and the IBIS-AMI files. You can see here's the IBIS file and the AMI and the bottom line and the .h and the .cpp. Okay, so you double click on the configuration.bat file. Okay, and when you do that, Windows Command Shell opens up and the CMake process is run and generates the Visual Studio solution. You'll see this in the next slide. So here the Command Shell display is shown and the CMake automates building the Visual Studio solution. The directory build-win64-Visual Studio 2019 is created with all the detailed structure and files needed by Visual Studio. In this directory, the only file we're interested in is the one called ami_solution.sln. A lot of other files, but you really don't need to be concerned yourself about this one. When you double click on this SLN file, the Visual Studio opens up, and that's what we'll see here. So observe the display for the Solution Explorer. It's circled, and the output window, it's circled in red. And you might have to use the View menu at the top toolbar to display these windows. And the IBIS-AMI and source code is in the subfolder below the AMI-TXFFE area. So now we want to set the solution configuration to release. You can see that encircled at the top. And then you want to right mouse click the install. You can see that circled in red. And you want to left mouse click on build. You can see that circled in red. Okay, once that's done, the output displays the build success message. It does the build, the compiling, the linking, and installation, and there it is. We're done. Okay, and when you go to the folder output-vs 2019 with the subfolder release-AMI, you'll see the files installed in that folder. Now, you can see that the one-click step for creating the Visual Studio solution, complete with all files, is as simple as possible. You can see that the one-click step to use Visual Studio Solution to compile, link, and install the IBIS-AMI model files is as simple as possible. The resultant IBIS-AMI and DLL files are ready for use in any channel simulator. So our last step is to use it in a channel simulator. And so here we use the free channel simulator on my website at www.serdesdesign.com. The web-based channel simulator is available for free for anyone to use. It supports NRZ and PAM4 with many built-in features, but you have to sign up and register to use it. Registration is required to gain access to the tools. And so the channel simulator effectively follows this flow diagram. It supports the transmit and receive IBIS-AMI models. It supports a total channel that includes the transmit IBIS portion, transmit package, the channel, any receive package, or receive IBIS portion. And each of those portions can be defined with S parameters. The transmit and receive IBIS-AMI sections can be defined using behavioral models. There are many behavioral models that are built into this free channel simulator for defining CTLEs, FFEs, CDR, EFE, LTI models, NLTV models, as well as using the IBIS-AMI models. So it can also generate IBIS-AMI models from the transmit and receive behavioral models. This free channel simulator also supports receivers and electrical repeaters. So in using these transmit FFE files with the channel simulator, it was used with a channel that used NRZ signaling at 25 gigabits per second, bit-by-bit mode with 100,000 UIs, and using a differential channel with 25 dB loss at Nyquist, which is at 12.5 gigahertz. And the taps were set to the values that provided this optimal eye diagram. So, do you understand that a free channel simulator is available to all? Do you understand that it supports NRZ, PAM4, behavioral modeling, IBIS-AMI, model generation, repeaters, and more? And we're doing all this with free tools. Any comments from anyone in chat? Let me hear from you. I think you can see that there's a lot of value here. So this webinar showed you how to create, build, and simulate IBIS-AMI models using free tools. The create process includes creating IBIS-AMI and C++ files using templates. The automated build process is based on the free Microsoft Visual Studio tool and the free CMake tools, and results in IBIS-AMI models that can be used in any channel simulator. The IBIS-AMI models can be used in any channel simulator, including the free SerDesDesign.com channel simulator. So, were you happy that you came to this webinar? Do you realize the advantage you have in using these techniques? Do you agree that this approach is going to make creating IBIS-AMI models easier, more enjoyable, and more effective and less costly for you? Can you see yourself applying what I showed you today, even if you use only a tiny fraction of what you discovered? Would you say our time was well spent? Let me hear from you in chat. There's a lot that we've gone over very quickly. Now you'll get the files that I'll be providing you, and you'll be able to compile and link and use the IBIS-AMI model from the files that I do give you. And you can see that the process is simple. Using all free tools, you'll be able to use the AMI model in the channel simulator as well. Okay. Some of you are commenting that you've gotten value out of this. I'm glad to hear that. Good.